Hi there, thank you for joining me. I'm going to be doing a drainage density map using ArcGIS, and a lot of people have asked me this question. In fact, I'm doing this video as a response to a question from one of my colleagues who is far away, and I decided to do a YouTube video and send him the link so he can watch it. When doing a different kind of hydrological analysis, watershed analysis, water resource management, or different kind of things within your study area or catchment area, you might want to have an idea of your drainage density. So I decided to do this video as a response to a question. There are several ways of calculating drainage density. Some just do a basic calculation which says the sum of all the stream lines within your study area divided by your total study area, which is the most common drainage density analysis. But come to think of it, that gives you a result only in values per unit, maybe per kilometer unit or per square meter unit. What if you want to look at this density on a map and easily spot out areas that are having higher drainage density or higher streams? So maybe before you go into the field to do a survey, you want to have a look at and pinpoint the areas that have higher drainage density and places with lower drainage density. Maybe you have particularly interesting places you want to visit when you're on the site. So that's what this video is going to be about. To start with, I have my study area boundary, I have my stream network here as a raster, and I have my stream network here as a feature class. Well, I did this, I converted it to a feature class because I wanted to show you the most popular way of doing it, which is the sum of all the stream length divided by the total area of the study area. So I've gone into the stream feature class to create a new field called the length, which is in kilometers. So these are the kilometer length for each of these feature stream lines within my study area, and I'm going to be using this to calculate a drainage density, which is one way of doing it. So this is the normal formula everybody knows. A drainage density is equal to stream length divided by area. So if I just go into my stream attribute data again, I can just right click on the length kilometer title, and I can click on statistics, and on sum, this is the total length of all the stream within my study area, and I can copy that, and I can go into my study area, open the attribute table, and create a new field and call it DD for drainage density, and I can just make that a double field and do OK. And because this is the total area of my study area, I can use this to calculate the drainage density. So what I will do is I'll go into the field calculator, and because my formula is the total length, which is what I've copied out, divided by my area, which is the area square kilometer, and I just do OK. So my drainage density within my study area is 0.67 per square kilometer. So I have a drainage density of 0.67 per square kilometer, which is fairly okay. Well, it really depends on the size of your area and the threshold if you use to determine your stream network. So that's one way of doing it. So if we can see, this might not be a really good result you want to show somebody. Where is it again? So just saying a 0.67 drainage density isn't really much of a visualization for somebody to see, or when you're trying to make a presentation about your findings. So that's why I want to show you guys how to do this in a more visual appealing way, if I may say. So I'm going to be using a tool called focal statistics. I'm just going to type in focal, and this is focal statistics. And what I'm going to do here is I'm going to bring in my stream network it works with all your raster data sets. So I'm going to bring in my street network, and this is where the magic happens. It takes a while before you get to understand how it works. It takes me some time also to really get around it. You need to play around with it and understand the size of your data, your study area, to understand what exactly you really want from this tool. So what happens is there are different ways of like a search radius. There's a circle, there's a rectangle, and irregular and weight. You can read all of them here in the help bar, but what I'm going to use here is the circle. So I'm going to search within a radius around cells. So if I leave it at 3, which is the default here, I'm saying search within the 3, search within the radius of 3. Then I can choose a statistics type here. In this case, I want to use sum because I want to sum up all the drainage lines within the radius of 3, but I'm going to use a much more higher number here, something like 20 to start with. I mean, like I said, you can always play around with this and see how it works. So if I do a search radius of 20, it's going to look into my stream data, my stream network, and do a search radius of 20 radius by circle, and make a sum of the stream that falls within the radius of 20 within my study area. And if I just click on OK, it's going to generate a new raster, which is going to look like this, which is basically a high drainage density and a low drainage density. But right now it doesn't really make much sense. So what if we do a reclassify, or if I just quickly symbolize this? But if I want to make it a permanent data set, I will want to do something like a reclassify. So I'm going to use the reclassify tool, and I'm just going to type it out. It's under the spatial analysis toolbox, and I can just drag in my focal statistics I just created in here, and I can go into classify and bring it down to just 2 classes because I want to know the highly dense drainage areas and low drainage dense areas. So it's going to be a wet area and a dry area basically. So and here you need to choose a threshold. I'm going to say for my data, again you can play around with this. For my data, I'm just going to say since it goes up to 137, I probably might say areas from 0 to 80 is going to be dry, and 80 upwards is going to be wet. So this is going to be my highly dense areas with basically highly dense drainages are within this 80 to 137, and I can just call this DD again for drainage density and just do it OK. And this is going to reclassify my data set into 2. And what I'm getting here is a drainage density map, and these areas that are blue, that have purple rather, that have this value of 1 are the dry areas, and the green areas are the areas with the high drainage density basically. So this gives you more idea of what you should be expecting, that if you're going into the field, or this can even help you in your spatial analysis when you're trying to do different kind of analysis, like watershed analysis, like water resource management, finding areas with higher drainages, or looking for the suitable place to plant some crops which require a high amount of water resource. So all these kind of things you can do with a drainage density map. Again, you can play around with the tool, get yourself familiar with it. It's a very useful tool. I just thought I'd show my friend. Hope you enjoy it. Alright then, thank you very much, and if you like this video, you can just feel free to hit the like button below. Thank you.